Assalamu alaikum. I am Dr. Pervin Akter, Professor and Head, Department of Physiology, Bashundhara Ad-din Medical College. Today I am going to deliver my lecture on transport of carbon dioxide. Carbon dioxide is an important respiratory gas. Its concentration is less in atmospheric air, but in the body, due to metabolism, large amount of carbon dioxide is produced. It is then transported from tissue into the atmosphere, and then it is then transported from tissue into the lung alveoli, and then from the lung alveoli it is expired into the atmosphere. Partial pressure of carbon dioxide. We know the partial pressure of a gas in a solution is determined not only by its concentration but also by its solubility coefficient. Carbon dioxide is physically and chemically attracted to the water molecule, whereas others are repelled. When the molecules are attracted, they can be dissolved more in the solution without building up any excess partial pressure in the solution. Carbon dioxide is more than 20 times as soluble as oxygen. So, diffusion of carbon dioxide is 20 times as rapidly and as oxygen. So, the partial pressure of carbon dioxide is less than 120 than the exerted by oxygen. Therefore, pressure difference required to cause carbon dioxide diffusion are less than the pressure difference required to cause oxygen diffusion. Carbon dioxide is constantly diffused from the pulmonary capillary into the alveolar air. In alveolar air, carbon dioxide concentration is more due to continually exchange of carbon dioxide through the pulmonary capillary into the alveolus. But in the expired air, its concentration is less due to the decreased concentration of carbon dioxide in expired air due to mixture of dead space air and alveolar air. Now, the transport of carbon dioxide from the tissue into the atmosphere. We know due to metabolic activity, large amount of carbon dioxide is produced into the cell. Then carbon dioxide is released from the cell into the blood. First, the diffusion of carbon dioxide from the cell into the interstitial fluid. Intercellular partial pressure of carbon dioxide is 46 mm of mercury, and interstitial fluid partial pressure of carbon dioxide is 45 mm of mercury. So, the 1 mm of mercury pressure difference causes diffusion of carbon dioxide from the cell into the interstitial fluid. Then the transport of carbon dioxide from the interstitial fluid into the blood. Interstitial fluid partial pressure of carbon dioxide is 45 mm of mercury, and partial pressure of carbon dioxide arterial blood entering the tissue is 40 mm of mercury. So, the 5 mm of mercury pressure difference causes partial pressure of carbon dioxide into the interstitial fluid into the blood. Transport of carbon dioxide into the blood. Carbon dioxide is transported in the blood in the three forms. In dissolved state 7%, in the form of bicarbonate ion 70%, and in combination of hemoglobin and plasma protein 23%. Dissolved state carbon dioxide is which is transported in 7%, which exert the partial pressure. Transport of carbon dioxide in the form of bicarbonate form. The dissolved carbon dioxide formed by the metabolism enters the RBC of the blood and reacts with the carbon water and form the carbonic acid under the influence of the carbonic anhydrase enzyme. Carbonic acid then dissociates into hydrogen ion and bicarbonate ion. Hydrogen ion combined with the bicarbonate buffer system, and carbonic acid enters into the plasma in exchange of chloride ion by the bicarbonate chloride carrier protein. This is called the courtship mechanism. And transport of carbon dioxide as the carbaminohemoglobin or combination of hemoglobin and plasma protein. Carbon dioxide also combine with hemoglobin to form the carbaminohemoglobin by very loose bond, so that carbon dioxide easily released into the alveoli. A small amount of carbon dioxide also combine with plasma protein and transport in the same way. Last, the diffusion of carbon dioxide from the blood into the alveoli of the lung. Partial pressure of carbon dioxide of blood at the arterial end of the pulmonary capillaries is 45 mm of mercury, and partial pressure of carbon dioxide of the alveolar air is 40 mm of mercury. So, only 5 mm of mercury pressure difference causes carbon dioxide of diffuse into the from the pulmonary capillaries into the alveoli. From the alveoli, partial pressure of carbon dioxide is expelled out by the expired air. So, an average of 4 liters of carbon dioxide is transported from the tissue into the lung in each 100 mm of blood. Now, the coercive mechanism. What is the coercive mechanism? Since the more bicarbonate ion formed in the RBC blood, they passes out from the red cell into the plasma in exchange of chloride ion that passes from the plasma into the red cell due to the presence of bicarbonate chloride carrier protein in the RBC cell membrane. This is called the coercive mechanism that I already explained. What is the importance of the coercive mechanism? It is transport the carbon dioxide as the bicarbonate form, and it corrects the alkalinity of the RBC. Now, the Halogen effect. Halogen effect means binding of oxygen with the hemoglobin tends to displace carbon dioxide from the blood. This is called the Halogen effect, and it is important for promoting carbon dioxide transport. Halogen effect occurs mainly in the lung, and combination of oxygen with hemoglobin in the lung causes the hemoglobin to become a strong acid, and this in turn displaces the carbon dioxide from the blood into the alveoli in the two-way. The more highly acidic hemoglobin has less tendency to combine with the carbon dioxide, thus displacing much of the carbon dioxide. And increased acidity of the hemoglobin also causes it to release excess of hydrogen ion, and this in turn binds with the bicarbonate ion to form the carbonic acid. So, this carbonic acid then dissociates into hydrogen ion and the carbon dioxide and water. Then carbon dioxide is released into the alveoli of the lung. So, this is called the Halogen effect. So, this is all about my lecture on the carbon dioxide. So, Allah Hafiz. Thank you all.